All right, for the last video of section 7.5, we've got a pretty simple one. You already know how to take the inverse of a function. In this one, we haven't looked at the graphs of rational expressions too much. We've looked at how to determine the transformations based on the general form of a over x minus h plus k. But besides that, we haven't really done much with them. You do know that the graph has asymptotes and it's made up of hyperbolas, but besides that, we haven't really done a lot with graphing them. We're not going to do that much, but we do want to be able to look at a graph or a function and determine whether the inverse is a function as well. Now, one easy way we can do that is by looking at the horizontal line test. So you've heard of the vertical line test with a function, which means if you take a vertical line, so if we do a vertical line like this and go from left to right and it never passes through more than once, that means that our function, that our graph is a function. Now with the inverse, if we take our function and we place a horizontal line, so if we take a line from left to right, a horizontal line, it's not very straight, I apologize, but we take that line and we move it up or down, if this line never crosses more than once, then we know the inverse is a function. So it's a really easy test. Again, you take a horizontal line, so left to right, and you move it up or down. And if at any point there's never the crossing of that line more than once from our graph, you know that the inverse is a function. So very basic test to determine this. You can just look at the graph of a function, and using this horizontal line you can tell if its inverse is a function. So it's important to remember that because you want to be able to tell this just by using the functions graph. Now we also want to know how to find the inverse of a function. So you've already done this. What you want to do is you take your function and you replace the f of x value with y. So you're setting y equal to your function. Now this finding the inverse is where you're going to replace x with y. So you flip your x and y variables. So you're going to have x where y was and y where x was. Again, very basic. You guys remember how to do this, so don't forget. So you replace x and y, and then what you're going to do is you need to solve for y. So you're going to go ahead and you're going to have an equation here, and all you need to do is shuffle things around in your equation so that you have y by itself equal to some expression. So here, in order to solve this one, what we would do is we want to cross multiply. So multiply both sides by y plus 3. So cross multiply here. On our left side, our denominator is just 1 with x over 1. So we multiply 1 by 2. We're not going to end up with any change on the right hand side. So we have x times y plus 3. So we can go ahead and divide both sides by x to get y by itself. So divide by x, we get 2 over x equals y plus 3. To get y by itself, subtract 3 from both sides. So we get our inverse right here. It's just inverse equals 2 over x minus 3. So that's how you find an inverse. Very simple. When you go ahead and graph it, so this red one is our graph of 2 over x minus 3, and you'll see it is the opposite if we flip it over our x-axis, not our x-axis, our x line, y equals x. So it's just a reflection over the line y equals x. So very basic on this. The key here is remembering how to find the inverse of a function. Remembering the horizontal line test, but most of the time you'll be given the graph of a function. So if you're able to just, put a line across, you can even put your hand left to right on the graph and move it down or up, you'll see that it is a function if it doesn't cross more than once. Alright, so the example that I want you guys to do right now, if you go right here, I want you to do problem 9. Now, don't worry, there's nothing graph-wise you're going to do. I just want you to look at this function, 1 over x minus 2, and determine whether the inverse is a function. That's the horizontal line test. That is a function, I'll tell you. All I want you to do is find the inverse. So find the inverse for 1 over x minus 2. Find the inverse for 1 over x minus 2. Remember all of our steps for finding the inverse of this function. Good luck. That's all you have to do. Very simple on this one. Find the inverse of our function 1 over x minus 2. If you have any questions, just rewind a little bit and see the examples that I just did.